Hello everyone, welcome to the first session, Definition of Statistic Non-Parametric. With me, Erna Fransisca and Sihotang. So, let's start. After finishing the module, you can recognize either parametric and non-parametric, and then you can understand which method to use, either parametric and non-parametric. And you can use the non-parametric for the data analysis. But do you know what is the difference between the parametric and the non-parametric one? So many tests of a statistical theory using the parametric one. But in here, you will learn about the non-parametric test. Such tests are called the parametric tests because they have full the assumption, like the data and the sample are randomly drawn from a normally distributed population and then consist of independent observation except for the pair values. And then you can see the data consists of values of an interval data or the ratio measurement scale. And then you have a prospective population of approximately equally variances. And then most data in the parametric data are the large data, not the small data. And then you can resemble a normal distributions for this assumption for most of the parametric testing in a statistical theory. And then you maybe will see the data that not filled with the non-parametric or maybe not filled with the normal distribution data. So it's where the non-parametric come into the play. So non-parametric methods require minimal assumptions, which is no normal distribution, no ratio data, and so on. And then the minimum sample for the non-parametric test is required for not a large number. For the minimum data, it consists of about 30 data. It's based on the book from Pitt, 1997, and from the Salkin from 2004. So they noted that the most researchers suggest for N minimum for the 30, and under 30, it's okay for the non-parametric testing. So the non-parametric statistical procedures consist of 4 steps. The first one is the hypothesis to be tested does not involve a population parameter. And the second one, the data have been measured on a scale weaker than the required data at the parametric procedure that would otherwise be employed. The third one, the assumption necessary for the valid use of a parametric procedure are not met. And then the fourth one is results are needed in a hurry and calculation must be done by hand. So mostly the calculation is a manual calculation, but you can also use the statistical tools for do the statistical calculation in here. For example, you have a case. In here, your samples do not resemble a normal distribution. In here, we can underline the normal distribution are not met. And then you might have learned a strategy that modifies your data with use of a parametric test. So in here, you can see that the removing outliers may be highlighted in here. If justified, extreme values or maybe called the outlier can be removed to ensure the data better represents to the target population. However, identifying and also the removing outlier is often complex and requires careful consideration and may be harmful for the origin data that consists of small data. So in here, you can use applying transformations for repairing the data or mix the statistical method in the data calculation. So in here, you try the mathematical transformation such as the squaring values or the logarithm natural, or maybe you have another calculation to make the data as you want, can sometimes make the data suitable for the parametric test. But sometimes this transformation works doesn't meet your expectation for the tailored data. So in here, especially for the not always work data, you have a long tail distribution in here. So what is the solution for the case of the data that consists so much of outlier, but it consists of small data and not to match the normal assumption? So in here, you can use the non-parametric test. When the data does not meet the parametric assumption, and then you also try the removing outlier, and then you also try the transformation working in the data, you can use the non-parametric testing, because in here you find the alternative that does not rely on strict distributional requirement. So what are the advantages and the disadvantages of non-parametric tests? Make fewer assumptions. This is the first advantages of the non-parametric test. Non-parametric testing in the statistical procedure are not have so much assumption. So in here, the assumption just consists that the data are numeric, or maybe the data consists of scale or nominal, and so on. So it must be a simple scale data. And then you have the wider scope. So either the data are not met the distribution of normal distribution, maybe can't use the parametric method. You can use the wider scope to compare the parametric test that actually assume that such kind of distribution. The third one, you can don't mind about the need to involve of a population parameter, because in here in the statistical non-parametric testing, you don't need to involve population parameter. What is the meaning of the population parameters in here? So parametric tests involve specific probability distribution, and the tests involve estimation. But in the non-parametric, you can just find the estimation data using such a method like a ranking data, or maybe you can find a data by the originally testing using the non-parametric test. So non-parametric does not involve this kind of population parameter estimation. But before the last advantages, the advantages in here is one of the benefit of the use in the statistical non-parametric. The chance of their improperly used is small. Since the non-parametric testing depend on the minimum set of that set, so the chance of their being improperly used is small. So in here, the applicable, even when the data is measured and on a weak measurement scale, it also can be done using the statistical non-parametric testing. So the main advantages of the non-parametric test is it's easy to understand because so many methods actually in the non-parametric testing. And here we will learn about two methods in here. So it has the minimum preparation in mathematics and statistics because we can use the calculation using calculator, using Excel, and such a simple tools. So that's why the computation can quickly and easily be performed or be measured because the calculation is easy, but use focus and good understanding on it. But what about the disadvantages? So the first disadvantages about using this statistical non-parametric is may waste information. So the researcher or maybe the observant or maybe the employee using this statistical non-parametric may waste information when parametric procedures are more appropriate to use. In a case that you have the parametric and the non-parametric, and then you use the parametric and then you use the non-parametric, so it must be may waste information if you use both of them. The second one is difficult to compute by hand for large samples. So non-parametric testing is the use of the small data. So it must be difficult for the large samples because we use the very conventional calculation using the calculator, or maybe the scientific calculator one, or maybe the Excel and so on. So, and the third disadvantage is the tables not widely available. So you can use, so the often special tables in critical values are needed for the test statistics. So you have to prepare the tables of Wilcoxon, of the binomial, and so on, of the chi-square, and so on. So you have to gather them all that are not widely available in every books or every website. So as a summary, the non-parametric can be used when the data distribution is unknown, the data is not following the normal distribution, the sample chosen is not by random sampling, and then the data group variance is not the same, and the last, data has measurement scale that are different. So as the reference, you can also find more depth by this book by Corder Chewy and Forman DI. That's all for the definition of statistic non-parametric, and see you in the next session.